Hey everyone, StatsGuru here, and in this video I want to talk about one of the most profound theories or theorems that we have in statistics. You may have heard of it. It's called the Central Limit Theorem. And so we will walk through a couple examples of how to use this, and I have a little definition here. So the Central Limit Theorem basically is if we have a well-defined mean and variance of a sample, and if we keep taking more and more samples, our data will approximate to the normal distribution. So why is this important? Well, this is important because we could have a distribution that is not normal, and as we take more and more samples from that distribution, it approximates to the normal distribution, which we can then use to find z-scores. We can then use to do all kinds of different testing. So this central limit theorem is really powerful and very important with everything in statistics. So that's kind of a quick definition of what the central limit theorem is. Now the central limit theorem does have a formula, and it is with z. So we're going to have z. So the central limit theorem works with z. As we approach the normal distribution, we then have z-scores, so on and so forth. So the formula is finding the z value. So how we do that is we take our x bar value and we're going to subtract the population mean, and then we're going to divide by the standard deviation over the square root of our sample size n. So this is going to be the formula when looking at the central limit theorem. Z equals x bar minus mu, or the population mean. We're going to divide that by the standard deviation of the population, and that's going to be divided by the square root of n. So we will go ahead and walk through a couple examples of using this formula and showing you how the central limit theorem works. Okay, in this first example, let's say we have a light bulb manufacturer and they have a bunch of light bulbs that they're producing. Let's say that they have a lifespan that is approximately normal, with a mean of 800 hours and a standard deviation of 40 hours. So we're going to find the probability that a random sample of these light bulbs will have an average lifespan less than 775 hours. One thing to point out when doing some example problems with the central limit theorem is you'll hear words like approximately normal. You will also be given a population mean, and you'll also be given the standard deviation. So those are some key takeaways when reading word problems, especially in statistics, is just to pick out some of the key words that you are noticing. If you're seeing approximately normal, you're given a mean and a standard deviation, you most likely will be working with the central limit theorem. So for this example, what I like to do is write everything down first that we are given. So we know that our population mean is 800 hours. And we also know that our standard deviation is 40 hours. What we are going to look at is if a probability that our lifespan will be actually less than 775 hours. So our x bar is going to be 775, and our n is going to be 16, which I actually forgot to write in here. Random sample of 16 bulbs. So I'll just go ahead and write that in. So our n is going to be 16 in this case. So after we've written down everything that we have, we can go ahead and we can use the z formula. So we know that z is equal to 775 minus 800. And then we're going to divide by 40 over the square root of 16. So once you do the top and the bottom parts, you get negative 25 divided by 10, which gives us a value of negative 2.50. So then the problem is asking, what's the probability that our average lifespan will be less than 775? So the question is, what's the probability that z is less than 775? Well, we went ahead and we transformed it, right? So now it's the probability that z is less than negative 2.50. So let's go ahead and jump over to the negative side of the normal distribution and figure out what this probability is. So here we have the negative side of the standard normal table, and our z value was negative 2.50, so we're going to go all the way down to negative 2.5, and of course it was 2.50, so our value is going to be this, 0.00621. So the probability that z is less than negative 2.50 is equal to 0.00621. In this case, we're just going to go 0.0062. What this is telling us that there's actually a 0.62% chance that a random sample from this light bulb manufacturer would actually average out a lifespan of less than 775 hours, which is pretty good, right? So they're right on track with their 800-hour average. So that's the first example of using the central limit theorem. Again, just looking at some of the keywords, what you're given, making sure you write everything down, and filling in the formula. Let's go ahead and look at another example. In this second example, let's say that you travel between home and campus on a city bus, and that averages 28 minutes with a standard deviation of 5 minutes. In 2 weeks, you rode the bus 40 times, which is probably a lot. What is the probability that your average time was greater than 30.5 minutes? So again, what are we given? We're given a mean, we're given a standard deviation, we're given that we rode 40 times, and we want to know what is the probability that our average time was actually greater than 30.5 minutes. Sometimes those bus rides can seem long, so you want to find the probability that it's greater than this time frame. So again, step one is to just write everything down that we're given. So we know that it averages 28 minutes and has a standard deviation of 5 minutes. Our x bar value is going to be looking at 30.5. And our n is 40 because we rode the bus 40 times. So let's go ahead and use the central limit theorem to figure out this problem. So we know that z is equal to 30.5 minus 28 divided by 5 over the square root of 40. So when you work this out, this is going to be 3.16. So the question was, what's the probability that our time is greater than 30.5 minutes? Well, we transform that, so now it's the probability that z is greater than 3.16. So let's go ahead and jump over to the positive side of the standard normal table and then get this value. So here we are at the positive side of the standard normal table, and we want to find the probability that z is greater than 3.16. Well, the good thing about that is it's actually off the charts because we only go up to 3.0. So if we were to even use the bottom right hand corner of this table, which would be the largest value possible, we see that we have 0.9990, and if you remember, the standard normal table uses probability from our z value all the way to the left. So what we'll have to do is we'll have to take 1 minus this probability. So let's go ahead and do that. So it's going to be 1 minus 0.9990, which equals 0.0010. So there's really a 0.10% chance that our bus rides actually averaged 30.5 minutes or more the 40 times that we rode the bus. So those were just two quick examples of using the central limit theorem. As always, guys, I hope that these videos are helpful for you working on statistical theory and stats problems. If you have anything that you would like to see worked on or a concept that you'd want examples for, make sure to comment down below. And as always, like and subscribe, and we'll see you in the next video.